Hello, how are you? This will be our second example on homogeneous. So this is going to be our second example on homogeneous. Make sure you watch the previous video where I introduce what is homogeneous and what type of substitution you are going to make. So here it doesn't looks like homogeneous. I have to express everything on the right hand side in terms of y over x. How I do that? So because I need a x below y, why not we multiply both top and bottom by 1 over x? So that's the trick. So you're multiplying both the numerator and denominator by 1 over x. And why you are doing it? Because I need a x below y, right? I need to express that y over x. So let's actually do that. When I multiply this out, you have y over x minus 4. Remember, x and 1 over x cancel each other. And here I get 1 minus y over x. So now you can see the right hand side is actually in terms of y over x. So the substitution is always the same for homogeneous. Is going to be v equal to y over x. You need to remember that cross multiply before you take the derivative. So I cross multiply, then I take the derivative. So dy dx, and you are using the product rule. So the derivative of v times x plus v times the derivative of x, which is 1. And now this goes in place of dy dx, and in place of y over x I have to substitute v. So all of in place of y over x I have to substitute v. So let's do that. So at the end of the day, what I get, let's see. So I end up with dv dx times x plus v equal to v minus 4 over 1 minus v. Let's subtract v from both sides. So this v, I can bring it on the other side, minus v. And I can combine these two fractions. There's 1. I can combine these two fractions. So I can multiply both numerator and denominator by 1 minus v. If I do that, so let's combine these two fraction, copy the left hand side. I copy the left hand side. So the common denominator is 1 minus v. And here I have v minus 4. Now I'm multiplying here. And don't forget that minus sign. So when I multiply minus v times 1 is negative v. And then when I multiply negative v times negative v, that's plus v squared. So this cancel out. I end up with v squared minus 4 over 1 minus v. So let's move all the v to one side and all the x to the other side. So I'm going to move this to the other side by flipping over. In other words, I multiply both sides by the reciprocal. And exactly the same way, I'm going to move x over dx on the other side by flip. Just like if you have, I'm just giving an example here. Let's say you have a 3 over 2 times 5 equal to, let's say, x, right? If you want to move this 3 over 2 on the other side, I can just write 2 over 3, because you're multiplying both sides by 2 over 3, right? So think about in terms of the flipping. When there is a multiplication, right? When there is a multiplication, when you move a product, a factor to the other side, you can just flip over. If you only have a multiplication on, if you only have multiplication, no addition and subtraction, only multiplication, you can do that. Just save some time if you think about in terms of flipping. So let's do that. Uh, so if I flip over, I get 1 minus v over v square minus 4, and of course you have the dv. Don't forget the dv, right? That goes here, equal to, I flip x over dx, so that's become dx over x, which is, of course, I can write as 1 over x dx. Now you take the integral of both sides. Now this side is easy. That will be ln of x plus c. Don't forget the absolute value. Now how you do the integral of this side by hand without any computer showing all the work, right? So this is an example of the partial fraction. So let's concentrate this one. So to make sure you review partial fraction from your calculus 2. But I'll show you in this here. So you start by factoring out the denominator. So you probably recognize v square minus 4 is v plus 2 times v minus 2. So I can use the partial fraction a over v plus 2 plus b over v minus 2. So let's solve for a and b. Now whenever there is only linear factor, so v plus 2 and v minus 2 are linear factor. So when they're only a distinct linear factor, so if we have a distinct linear factor, there is a trick which will save you a lot of time to find a and b. It's called hide and seek method. So in this method, you can actually find a and b directly without any calculation, really. So let's take a look at it. It's very interesting. So to find a, look at the factor below is v plus 2, right? So that will be 0. My v plus 2 is 0 if v equal to negative 2. So you substitute this negative 2. So you hide the factor v plus 2. You hide it, right, in your hand. Just hide it. And the rest, you substitute v equal to negative 2. And that will be your a. So again, to find a, you look below the factor when that will be 0. In this case, v is negative 2. So you hide v plus 2 from the left, and and all the rest you substitute v equal to negative 2. So let's do that. I'm substituting v in place of v. I'm substituting negative 2. And that will give you 3 over negative 4, or negative 3 over 4. And you keep doing it for all your a, b, c. In this case, you only have a and b. So I'm going to erase this here so I can show you the other one. So let's actually erase it. Very good. Now let's do this one. So to find b, you look below. The factor is here b. So and the denominator I have v minus 2. When that will be 0? Well, when v is equal to 2. So now you hide v minus 2 because that is the denominator. So you hide v minus 2 from the left, and in the rest you substitute v equal to 2, and that will be your b. So I replace v by 2. And if you do that, you end up with negative 1 over 4. So it's a very shortcut, a good trick which will save you a lot of time. So this goes in place of a, and this goes in place of b. So let's do that. So we're only doing the left hand side now. So if I replace a, so let me write, so 1 minus v divided by v square minus 4 is equal to a over v plus 2, but my a is negative 3 over 4 over v plus 2, plus b, which is negative 1 over 4 divided by v minus 2. Now I can do the integral. So the integral, I can distribute this integral under the plus sign. So the integral of the first term plus the integral of the second term. So those are quite easy. Remember, it's a shortcut to remember that the integral of 1 over ax plus b dx, right, in general, is 1 over a ln of ax plus b. So that will help you here. In this case, v play the role of x, but that's the idea. And here in both of this integral, the a is actually 1. The coefficient of v is actually 1. So that's actually makes things even easier. So let's bring this other on the outside the integral, and then the integral of 1 over v plus 2 is ln of v plus 2. In this case, 1 over a is just 1 over 1, which is 1. I don't need to write it down. Don't forget the absolute value symbol. Similarly, I take out the negative 1 over 4 outside, and I end up with ln of v plus v minus 2. Excellent. So let's write that down. So that is the answer for the left hand side. So let me copy that. That is the answer for the left hand side. And by the way, I'm going to replace v by y over x. You always do that. You replace v by y over x at the end, because v is equal to y over x. So that's a very important step. Equal to the right hand side. The right hand side, if you remember, we did the right hand side. The right hand side is ln of x plus c. It is actually, perhaps you can simplify this, using some of the properties of logarithm. If you want, you can do that. So this is your implicit general solution, because y is not solved in terms of x. But perhaps you can simplify, for example, you can multiply both side by negative 4, and then you can move the number in the front as a power. So let's see how much I can simplify. I mean, this is optional, but this will make the solution looks very good. So let's actually try that. Let's multiply both sides by negative 4. Let's do a little bit of simplification. Let's do multiply both sides by negative 4. So if I do that, I get 3 ln of y over x plus 2 plus ln of y over x minus 2 equal to minus 4 ln x plus negative 4c. But negative 4c I can just replace by c, because c is negative 4c is this arbitrary constant, and c absorb any constant, which I explained in the beginning of this series. So now it looks at least a little bit simpler, right? I can make it even simpler because I can bring this c3 in the exponent as a power, right? I can do that. So let's do that. And the same thing I can do, I can bring this negative 4 in the exponent, right? Okay. Now a trick that we can do is this. See, I can replace my c by ln c because that is an arbitrary constant. So I can replace c by ln c. At the end of the day, it will be an arbitrary constant. And ln goes from, ln function, the range is goes from negative infinity to infinity. So if c is between 0 and 1, you get all the negative number, and when c is 1 or more, you get 0 and to all the way to infinity. So end up with all the possible number there. Okay, so, oh, sorry. Okay, so now if you remember, one of the properties of the ln, right? Ln of ab is ln of a plus ln of b. So you can use this to combine these two into one ln. And in this side, you can do the same thing. You can combine this. So I can write this like that. And finally, I can forget about the ln to both side. You exponentiate both side. So if I do that, I end up with this, only the inside. So this is equal to that. Okay, at least I get rid of all the ln. It looks simpler, right? So if I do that, now here I have to put this cube outside the absolute value. Um, I can actually combine this two absolute value into inside the one absolute value. So let's actually simplify a little bit. So I can actually do some simplification here. So I can put everything into one absolute value. Actually, because of this cube, I think it's a good idea not to do that, because I have this cube. I have to I have to be a little bit careful because you cannot really move this cube inside um, inside the absolute value. Oh, I'm sorry. I apologize. You can do that actually. So you can actually write that down. Yeah, yeah, it's okay. And then in this side, I can just write this in c times 1 over x to the 4, because remember, x to the power negative 4 is actually 1 over x to the 4. But to break it down into two parts, you can write that inside the absolute value is equal to the plus or minus the other one. So in other words, if I have something like the absolute value of a equal to absolute value of b, right? In that case, your a could be either b or it could be negative b. But I don't want to go that far. I think that's enough. Okay. As long as you get rid of the ln, this is good enough. So you can end up with two branches of the solution, one for the plus and one for the minus. If you want, you can do that. But I'll leave it like this. Thank you. And make sure you always remember that you can do it. Always remember that. Bye bye.